Contemporary high-definition video lenses have typically evolved into families of three: a wide-angle lens, a telephoto lens, and an intermediate standard lens. Behind the design of any specific lens, there are three forces. One, the production needs of the camera operators, the highly dynamic, competitive marketplace with the camera manufacturers and the speed with which they evolve cameras over a decade, and last but not least, our own evolution in optical design, tools, materials, coatings, all add up to the ability to produce an important new lens. The new lens that I'm going to describe is an HJ14 by 4.3 millimeter. So it's a wider angle, being 4.3 millimeter, a wide angle of about 96 degrees, and a 14 times zoom. Now, there are two primary design goals behind this lens. One is the operational attributes of the lens, and then very important, the optical performance of the lens. First, let me talk about the operational improvements. In this lens, based on tremendous input over the last decade from users all over the world, we went for larger aperture optics, increased sensitivity, better control of aberrations. We've already said the community wanted a wider angle and a longer focal range. And we wanted to also minimize focus breathing, that inadvertent movement of angle of view when you focus the lens. We wanted to enhance the digital drive unit, which is the primary tactile interface with the camera operator. I'd like to talk now about the optical performance of this lens. It's a big topic because, as indicated on my first chart, you will see we have 11 imaging parameters that collectively describe the performance of the lens. And each of these attributes can change every time we move the iris, or the zoom, or the focus. And that's the trick of optical design, is to manage all of these parameters to a very high level. Because, as we show in my next chart, when the lens is coupled to the camera and the camera ultimately produces the high-definition video, that video will have imaging attributes that are familiar and important to the camera operator. And they are sensitivity, sharpness, tonal reproduction, the exposure latitude, and then the all-important color reproduction. The 11 imaging attributes of the lens can be considered to apply an indelible imaging footprint to that video that you will get from the camera. And many of those attributes of the lenses are interlinked with a given video attribute, as shown on my next chart. For example, if we take the all-important sharpness of the lens, that's impacted by the contrast ratio of the lens, the resolution at the picture center, and the change in resolution as you go to picture extremities, the monochromatic aberrations of the lens and the chromatic aberrations of the lens all bear on the ultimate sharpness of that lens. Then the same with tonal reproduction, exposure latitude. So the lens is extremely important, that we must get all of these attributes optimized.